going to look at combinations of functions. Basically what we're going to do here is introduce some new notation. We've done many of these things before, but we've not really formalized it, and we haven't talked about how do we describe these in terms of notation. So not much is new here, but it's going to be a little confusing just because the way we describe it is going to be a little bit different. So I'm going to start off with an example, and then I'm just going to go through and define the notation and do some examples. Most importantly, I'm going to define a new way to describe something called the composition of functions. We've done it, we just haven't formally defined it. Okay, so for example, suppose I have a function, I'll call it April, and it's 7x squared minus 5x plus 3. Okay. This is basically a parabola. We've seen these things before, but there's another way to look at this. If I define three new functions, then I can define this function April in terms of Anna, Alvin, and Alexis. In particular, I can think of this as 7 times Anna minus 5 times Alvin plus 3 times Alexis. Okay. So I can think of new functions in terms of old functions. And if I can figure out what's going on with these old functions and sort those out, it's going to help me to adapt and figure out how to handle a situation where I get something new. Okay? So basically what we can do is we can multiply, divide, add and subtract functions. So let's just look at an example. So suppose I have 2 functions. Suppose we have Amber of x is x minus 4, and Artemis of x is the square root of x. So I can add them. So this basically just says take those 2 functions and add them, and I get x minus 4 plus square root of x. I can subtract. So we're going to get the Amber minus Artemis. I can multiply. Oops, I've got to be careful. That's not what your book says. Your book says this is a dot. I think I'm not spelling Artemis right. That will get you an arrow in the heart. So this is going to be x minus 4. So there's my Amber. And then I'm just going to multiply by that. And I can divide. Minus 4 divided by the square root of x. Okay. So that's all fairly straightforward, but be a little careful here because the range and domain of these things can change because you're working with new functions. Right? So for example, the domain of Artemis is all x greater than or equal to 0, but when I divide these things, right, Amber's domain is all values of x, but now this has to be all x greater than 0 because I cannot divide by 0. So be a little careful about that. The standard kind of rules apply. You just have to look at this final thing and ask for what values of x does this make sense. Okay. I want to talk about something different though, something called composition. And the idea is, what happens if I take the output of one function and use it as the input for another function? Okay, so let's start with an example. suppose I look at that function there, square root of x minus 4. The thing to notice is I'm taking the square root of something, and the something looks an awful lot like this function here. So what do we have? This thing looks like Artemis, and the thing on the inside looks like that function we're calling Amber. Okay? And so what we have then is, if I take Amber and then take the square root of that, that means that on the outside, I'm doing this operation to the output of here. So I can think of this. So what does Amber says? Amber says if you give me an x, I return x minus 4. What does Artemis do? Artemis says if you give me an x, you give me a number, you take the square root of whatever number you give me, but the number I'm giving you is that. So I get that thing. So this new function here I can think of as Artemis acting on Amber. And we call this composition. We're composing Artemis and Amber. Now we need to be a little bit careful, because if I switch the order, I'm probably working with a different function. So what this says? This says take Amber, and the number I'm going to give Amber is whatever I get from Artemis. So Artemis says taking a number, give you the square root. What does Amber do? Amber says give me a number and just subtract 4. So you're giving that number, so I'm going to subtract 4 from that. And notice I have two different functions in two different domains and two different ranges. Okay? So the order that we do things matters. Okay? And in terms of the notation, this first one we sometimes write like this. Is we're going to compose Artemis with this, so we'll write a open circle there. So this means the same thing as that. And likewise, if I switch the order, oops, be careful, a function of x. I'm going to take Amber composed with Artemis. Okay? So now this can be very confusing because an open dot means composition, a closed dot means multiplication. They're two different things. So let's go back and look at these two functions and just note what's happening that's different with these things. Okay? So let's see. Let's look at that function. What is the domain? The domain is going to be x greater than equal to 4, right? Or we could write it as 4 to infinity. What's the range for that thing? The range is basically I'm taking the square root function and I'm shifting it right 4 units. So I get that. So this range then is going to be, that should be open, 0 to infinity. I take Amber composed with Artemis. What did we say we got? We get square root of x minus 4. Okay, now my domain, well, I can only plug in positive values for x there, so that's x greater than or equal to 0. Or I could write it as 0 to infinity. Now the range, so this is now taking the square root function, but it's shifting it down 4 units, excuse me. So what is this? This is going to be minus 4 to infinity. Okay? So when I compose things, I'm working with different functions, and I've got to be very careful about trying to figure out what the domain range are of these new functions. Let me do one more example. So we'll go backwards this time. I'm going to start with a function and then try to find or define new functions that will be, I can write as compositions to get this new function. Okay. So what do I have? I have a function I'm going to call Alfred. And Alfred is going to be 6 over x squared minus 4. So I'm going to define two functions so that I can then write this function in terms of compositions of the old functions. So what is this? This is 6 divided by something. Okay. So whatever I'm doing down here, whatever this operation is here, I'm going to call this Adele. And this idea of taking 6 divided by something, I'm going to call that Angus. Okay. So what does that give us? So Adele is x squared minus 4, and Angus is 6 divided by x. And I'm being sloppy. Angus of x is this. So I claim that if I compose Angus with Adele, I will get that. So let's see. So Angus is last. We're going to have to wait to see what he does. What does Adele do? Adele says you give me a number and I replace it with x squared minus 4. That's your output. Okay? What does Angus say? Angus says you give me a number. Oops, sorry. Angus says you give me a number and I take 6 divided by that number. So I'm going to take 6 divided by whatever you give me, and I get that. And notice this composition of Angus and Adele gives me this new function. Okay? So it's going to be very important later when we start talking about functions, is if we give you some complicated new thing, can you define new functions that will allow us to write it as compositions? And this will allow us to look at both of these things separately.